AI PIL, Artificial Intelligence Promoted by Interactive Learning Loop, Scenario 1, Point of View of a Level 2 Operator.
Hi, my name is Sally and I'm a Level 2 MLOps operator. I've just been informed that one enhanced product stored within the Domino X catalog suffers from bad predictions. The product is an RGB acquisition over the city of Toulouse. The model is a building detector and we are looking at the raw prediction here. Pixels predicted as buildings are shown in blue. As you can see, looking up for bad predictions over the whole product is quite a tedious task. Thankfully, the uncertainty linked to this prediction helps me visualize areas where the network doubted its own prediction. The uncertainty is displayed in red. Uncertain areas are the most impactful ones. Hence I shall focus on these for the task of retraining the building detector. Let's focus on this noisy area for now. We can see a mix of wrong and right predictions, so the uncertainty guided us to a location where the network clearly doesn't know what to do. Please note that good predictions can be associated with a rather high uncertainty. That means the network has basically been lucky by predicting the right class on some doubtful pixels. Now the idea is to create ground truth labels in this area and then store it in the catalog. Using the AI PIL plugin, I can actually foresee how the ground truth will help the Level 3 ML engineers to correct the predictions and improve the network confidence. First, I select the model that has been used by the Enhanced Processing Service. Then I draw a region of interest over the noisy area. Clicking on Predict, I can see that the network hesitates. The results change a lot from one prediction to another. By clicking on the Annotations button, I can start the creation of the ground truth. Right-click our pixels labeled as non-building. I'm only using a few clicks here and there. This allows me to quickly create a sparse ground truth instead of having to fully annotate the area. By clicking on Retrain, I can train the model again on this area using the sparse ground truths and see how the annotations can help. While waiting for the retrain to process, please note that the model has been designed to accept sparse ground truths. It limits the amount of time I have to spend on creating a ground truth. The interactive learning loss is implemented inside AI PIL. That way every network that accepts sparse annotations can be retrained by AI PIL. Okay, so now that the retrain is complete, we can see not only did the accuracy improve but the overall uncertainty is actually largely reduced. Using the Predict button and a larger region of interest, I can confirm that my annotations did no harm to the network, even on more urbanized areas. Please note that there remains uncertain regions like this one. Again, the uncertainty captures relevant part of the predictions. Here buildings are hard to distinguish from roads and parkings, so the network could still use some help.
Scenario 2, Point of View of a Level 3 ML Engineer.
Hello everyone, my name is Brian and I am not in the kitchen. In fact, I'm using the MAPQS and I've been told my building detector fails significantly for products acquired over Africa. Well, this is no surprise to me, cause I told them the network's only been trained on US cities. Anyway, let's open AI PIL and see how bad it is, clicking on Predict and... Yep. It is indeed a disaster. The confidence itself seems to be lost in translation. The network is very confident where it fails and there is no epistemic uncertainty captured here because we're outside the network domain. Now let's go back to the basics and start focusing on a region of interest. We run the prediction. No surprise here. Not good at all. We're supposed to get a recall of 1 in this area. I have no ground truth available here, otherwise this would be no fun. So what I'm gonna do is draw a region of evaluation and start creating a lightweight ground truth. This ground truth cannot be sparse, which is the reason why the video is now sped up. Now I click on evaluation. In green are the right predictions. We want to minimize dark green predictions for they are not reliable. From blue to red are the wrong predictions ordered by ascending confidence. There's blue all around buildings, meaning the network is not quite sure where a building starts and stops. But we're training a detector, so this is just fine. However, some buildings are shown in red because the network is confident though it fails. Talk about intelligence, right? Anyway, the results of our evaluation are stored in MLflow, so we will be able to keep track on what we are doing here. Now, as you assume, I'm going to annotate the region of interest trying to help this poor model. And yep, the results are much more satisfactory here. Let's see how the evaluation progresses. But first, please notice that we keep track of every retrain model, so every time I come back from the kitchen, I know where to start from. The new evaluation shows much less dark green areas. Pretty much every buildings have been detected. And in the middle of red areas we can now see some light green pixels. Now the process keeps on going with another area. Again we annotate and retrain. The retrain is complete, let's evaluate again. The evaluation is now starting to feel right. The evaluation table shows the improvement so far for some basics metrics that have also been saved. Now it's time to check over the whole product. The prediction time is cut and you can see the overall improvement. Buildings with dark roofs are not well detected, and if you followed so far you have probably noticed that I only annotated white buildings. So you know what you have to do next, right? That is great. 'Cause it is time for me to leave. And if you have questions, well, I will be in the kitchen.
And that concludes this presentation. If you had to remember just a couple of things, please do not forget what follows. AIPL can work with your model. The retraining protocol and the uncertainty are computed within AIPL. Your model only needs standard entry points and to support sparse annotations. We can help you with that. The uncertainty proposed by AIPL mixes allegoric and epistemic uncertainties. Future works include using both independently. AIPL can be connected to your MLflow database. The models within your catalog will be made available for predictions, retrains, and evaluations. Every experiment done with AIPL will be saved into your database. AIPL supports multi-classes models even though Brian did not talk about it. Thank you for your attention. Any questions?